I'm going to share my screen for just a second. Let's see, okay, I think that'll be 2.
I will deal with all that when I get home.
Okay, for some reason that didn't share. Well, maybe my new toy isn't doing quite what I thought it would. Let me stop sharing and try sharing one more time. Bragging about that piece of software and then it doesn't work. That come up. Okay, well, evidently something's not quite working with just not going to share it. Okay, well, what I'm showing you here is a picture of Eric and DeepRacer. Just a quick heads up of what's coming up today. Eric's going to be talking about DeepRacer and machine learning. So we're really looking forward to that. Coming up next week, we're talking about the curse of the testing pyramid. And we're going to be talking about some ancient Egyptian curses and maybe things we can learn related to how we test our software. We're also going to give away a box of Count Chocula because that seemed like an appropriate thing to do as, kind of the whole Halloween thing. So be watching for that. The week after that, we've got Mark McKelvey talking about what Agile teams need to know about AI, followed by what is DevOps the next week. And then I think we've got Chris Lucian coming to talk about generate organizational-wide understanding with cross-discipline causal loop diagramming. So that's what's coming up. But today, like I said, we've got Eric. I'm very glad to have Eric with us. Eric's going to be talking to us about DeepRacer and machine learning. Eric works for AWS. He also does a lot of stuff on working with mental health hackers. I know it's a passion of his. So he'll probably tell us a little bit more about what he does, but looking forward to it. And so, Eric, I will turn it over to you. And thank you so much for joining us.
Thanks, Mark. Appreciate you having me on to talk about this today. Just to start out, who I am, where I'm from. Let's see, the slides aren't moving. My name is Eric Lee. I'm a senior solutions architect at AWS. Been here for a little over 4 years. I work with customers capital markets industry right now. My deep focus is in machine learning and data pipeline, stuff like that. I've been in IT for 30 years, kind of a younger, older person. Did an internship in high school back in the 90s. Actually got Novell certified before I graduated high school, if anybody remembers back in the NetWare days. Kind of ages a lot of us, so been around there. As Mark mentioned, I have a passion for mental health and IT. Went through burnout a couple times. Decided about 7, 8 years ago to start talking about my journey and relating with other people. Found a group called Mental Health Hackers, and I kind of run the Midwest area for that. So I go to a lot of conferences, do presentations on mental health and burnout in IT, and just love doing that. So if you have any questions about that side of the house, please do not hesitate to look me up. If you find me on LinkedIn or whatever, you'll see quite a bit of stuff that I've been doing in that area. All right, so today we're here to talk about machine learning and more specifically a subset of machine learning called reinforcement learning. And at AWS, we were talking a long time ago about how do we get machine learning in the hands of our developers and customers. And that's really where a couple physical items came about. And one of those is called DeepRacer. So I want to talk to you about that today and why it's cool and how it helps get people an introductory to AI, ML. And a lot of the customers that we use love doing this as a fun event. So this is what we're going to go over today. Don't need to read through all of this, but we're kind of going to do an introduction, see how the DeepRacer system works, why it's important. We'll talk about use cases in the real world where businesses are using reinforcement learning. And then I'll talk about where DeepRacer is going in the future. Now, I don't like to just present straight through, so this is going to be interactive. So I'll probably be asking a few questions here and there to just see how people are understanding the content, number one. But number two, please ask questions. You can interrupt me if you want to. I think Mark may have it on mute. So if you have a question, please put it in the chat. I'll be monitoring that. Mark, hit me up if I miss something over there, but no sense to wait till the end. I'm not going to bore you all for a whole hour on this. We'll probably get through in about 30, 35 minutes. If there's more questions, we'll talk about that. Sound good, everybody? Some thumbs up, stuff like that. Awesome. So let's start out by talking about AI and ML and where that really fits, right? So AI is something that encompasses every system that aims to replace human intelligence. So it's trying to make a decision or a judgment based on certain data. AI is the process of building these algorithms out, and they can take a process of information to inform future decisions. This could be as simple as writing a program with a series of if statements. When AI really came out, it's like, it's just if-then statements. And that literally is what it was back in the day. And depending on these conditions, which are evaluated, a particular result is returned, right? The earliest days I remember dealing with some of this, and I had a college instructor that was like, the soda dispenser machines where you put in quarters and you select an item. It's AI because it's just doing an if-then statement on how much money you put in to figure out how much money to put back out and which button you hit to return the soda. And this is really just a classical programming approach for AI. And it's suitable for some basic things, but it's really not suitable for complex or even dynamic problems at all. And this is where machine learning comes in. In the machine learning side, it's a subset of AI where you teach an algorithm to learn without explicitly being programmed to do so. So in other words, an algorithm is developed to automatically find patterns in the data, which allows future predictions to be made. Now, one thing I like to caution people, and I get a lot of this from my customers, is it allows future predictions based on patterns, but it doesn't do any true human reasoning, right? It's just going to look at patterns and go, oh, I see this, here you go. So we always have to be careful with the outputs that come out of it, and we'll talk a little bit more about that here in the future. So based on the learning that it's done, though, this algorithm builds and outputs a machine learning model. Now, this model is essentially a program which can be used to find patterns to make decisions or predictions for this new unseen data. Does anybody know how many types of machine learning there are that we use out there right now? The core 3 types. Anybody? No, I just said 3 types, so I just gave the answer.
Yeah.
There you go. So the first
Oh,
one.
how about? Can I go ahead? Can I go ahead, please?
Yeah, is there a question or?
Okay, I wanted to. You asked the question. The types of machine learning.
Yep, those are the 3 types up there on the. I accidentally kind of gave it away
okay.
there at the end, so it's
right,
going to be 3 types. So let's talk about these 3 types of machine learning in a little more detail, okay? The first is supervised learning, and this is something we've been doing for quite a long time. In this type of learning, every individual piece of training data has a corresponding label associated with it. That's the metadata assigned to it. And this tells the machine learning algorithm what the training example is. So as a result, the algorithm can then learn from this data and predict labels for unseen data in the future. So in this example, the algorithm is being trained to identify flowers. So it would be given training data with images of flowers along with the kind of flower each image contains, okay? The algorithm then uses the training data to learn and identify flowers in unseen images it may be provided in the future, right? And it'll also give you a percentage, a confidence score on how confident that is. And this is pretty straightforward. Can anybody tell me where there's been, for quite a while now, where mass metadata assignment is being done to help train models over the past 10 years? It's something you all have probably used and may have even used today.
Netflix.
Couches.
Yep, CAPTCHAs, there you go. Yep, anywhere where you're signing in and they're saying like, hey, can you tell me which pictures have a street sign or which pictures have a bridge? You are actually helping those vendors assign metadata to pictures so that when they train their models, that metadata is there. So you are mass training metadata for supervised learning models to be generated at scale. Kind of easy way to not have to pay people to do stuff, right? The second type is going to be unsupervised learning. And in this case, right, it kind of makes sense. There's no labels for the training data. The machine learning algorithm, in this case, tries to learn the underlying patterns or distributions that govern the data. So in the example in the picture above, the training data given to the machine learning algorithm does not contain labels to predict, but instead must identify patterns in the data itself. This can often be a benefit since it allows you to use massive data sets where labeled data may not be readily available. And in this case, if we send it a sunflower, it's going to say, hey, it seems to fit with this group. Unsupervised learning is kind of fun in the picture generation space. And it allows you to create fun pictures based off of general types of data that's been sent to it. So in this case, you could ask it for a photo of an astronaut riding a horse in space. It kind of knows what some of each of those are, but it's not 100% sure what this should look like or if it should be valid. And it's going to just kind of put that stuff together for you. All right, the last ML subgroup is called reinforcement learning, and this is what we're going to focus on the rest of today. And this is very different than the other two that we just talked about. In reinforcement learning, the algorithm learns from experience and experimentation, essentially trial and error, stuff that we've all done in the past, right? So in this example, the picture that I have here, AWS is training, or an Amazon is training a robotic arm in a fulfillment center to pick boxes up off of a production line and place them onto these mobile robots to transport where they need to go. So during the training phase, if a robot arm successfully places the box on the correct spot on the transport platforms, then a positive reward is given. However, if the robot arm gets it wrong, perhaps it doesn't pick up the box properly, or it places it, off to the side or not even on the robot, then no reward is given or a negative reward is given. So over time, through cycles and iterations, and it's going to explore around to try to figure out where to put it, the robot learns the correct action to take in order to maximize the rewards. Those last two words, maximize rewards, that is the ultimate goal in reinforcement learning model training. The system will always try to maximize the rewards. And I'll talk a little bit in here in a minute about how you do that when you're writing the model training components. So this is the type of machine learning used by DeepRacer, and we'll focus the rest of the day on. Can anybody tell me in their home life or in any non-work life environment where you would use this type of training, this reinforcement type of training? Mark's on top of it, training the dog. Yep. Conditioning. Yep. I think Mark's seen my presentation. Kids, Terrence, 100% right. Parenting, yep. Good job, Angela. Speech therapy, yep. So in the real world, we use this day in and day out with family, friends, all kinds of stuff, right? So you're going to reward positive behavior. You're not going to reward negative behavior. And over time, you get a super dog that is doing exactly what you want it to do. Yep, driver training. Insurance is the same thing. Insurance industry, right? The less wrecks you have, the less you pay, stuff like that as well. Yeah, we'll talk about how a robot understands the reward here in just a minute. So where is reinforcement being used in the real world? There's in the energy industry, it's being used a lot. Data centers for quite a while are using reinforcement learning models to try to understand consumption scenarios. So some of them will like do supplemental energy coming from the from the core energy providers to try to see if they can offset some of the costs there and what that will do to the environment. How to push cooling into certain areas and see what that airflow changes. Smart energy grids use a lot of reinforcement learning to try to predict different operating scenarios on where power comes from. My brother works for Kansas Electrical Co-op, and they get energy from 5 different locations. And they have some data scientists that will use reinforcement learning and some other models to try to predict where they need to send power to. Because with power at that scale, you can't store it, right? So they're trying to use these reinforcement models to try to see if we send this power there, we send that power there, what'll happen. In the transport and logistics area, it's been used for a long time to optimize traffic control systems. How quickly to turn green lights to yellow lights for traffic flow. And then in the supply chain, it's heavily been used to try to optimize routes or do dynamic ordering of supply items, stuff like that. In the finance industry, we're using standard analytics for a long time, but then it started getting into reinforcement learning in late 2017, early 2018 to try to predict future sales and stock price based off of selling these. So in the past, it was always just straight analytics where, hey, this looks good, I'm going to go buy that. But then with reinforcement learning, it's like, if I go buy that, what may happen somewhere else? Right? What are the side effects of that, and what do those look like? What's the snowball effect that can potentially happen? JP Morgan for a while was and still does in some cases uses automated stock market trading using reinforcement learning algorithms, and they're moving on to some even more advanced modeling as well too. But it's still a part of theirs. And then also in trade risk assessments, right? Kind of goes in with the future sales stock price stuff. So those are real world examples that are being used today in the business landscapes. There's many more. I have customers that ask me, is generative AI replacing this? I kind of go back to a statement I made earlier. Generative AI doesn't do any reasoning. And it's going to be a combination of everything. So generative AI has its use case. Reinforcement learning has its use case. They go hand in hand in certain places, and all that. Good question. Is reinforcement learning applied when doing load balancing among servers? Yes. In certain cases, it is. It depends on what the model for the analytics that's being used for that. Some of it is just traditional AI. If I see this, do that, or it's a straight 50% balance or something like that. If you're reading in numerous sensors and then allowing it to make a decision based off of a collection of a multitude of sensors, at that point in time, it's going to be using a machine learning model that could be partially reinforcement learning. Cool. So has everybody kind of got a base gist of what reinforcement learning is now? A little thumbs up. We all good? Yeah, awesome. So let's talk about AWS DeepRacer now. As I mentioned earlier, AWS was trying to figure out how to get DeepRacer into the hands of our developers. And we literally meant the hands of our developers with a physical car. So back in 2018, reInvent came out and AWS introduced this to all of our attendees there at the Expo Hall. And it's really a service which democratizes artificial intelligence and machine learning and makes it available to everyone, regardless of past skills or experience in the field of technology. The concept of DeepRacer is pretty simple. It's an autonomous car which you need to train to drive around a track. This is not dissimilar to real-world autonomous cars that are out on the road today. You can do a little bit of off-roading with it. I'll show you a little bit more about it here in a minute. So what does the vehicle look like? And I have one right here in my hand. So it's a 1/18 scale RC car. And if you take a look at it, it is standard RC car that you can buy off the track or buy off Amazon or anywhere else. You can go to RC Carport. So it has servos in here. It's got the motor in here. It's 4-wheel drive, 2-wheel steering. And at AWS, we just mounted a plate on the bottom that gives us a little bit of a riser. So all the parts on the bottom part, which is the RC car, are replaceable with standard RC car parts. Above that is a computer. Now this is an Intel Atom computer that you see on the screen. It's got Wi-Fi on it. It's going to run Ubuntu 2004. And you could load Windows on it if you wanted to. It's only got 4 gig of RAM or whatever, or 4 gig of RAM and small processing, so it really wouldn't do much. It's got multiple USB ports, and the camera that's being used, you can see there is a 4 megapixel camera, and it's just USB based, so it just snaps in there. You can upgrade on the bottom. You can add a second front-facing camera, so I would then have another one mounted to the side, and you can mount a LiDAR sensor on it. And what that gets you, can anybody tell me what 2 cameras facing front will get you that 1 camera does not?
Stereo vision.
Awesome, Satish, great. Depth perception, 100%. And then the LiDAR sensor, anybody play around with LiDAR? What does that get you?
Xbox.
Yeah. So when you get to the next level, once you get through the base level and learning how to do it with 1 camera, with 2 cameras and with the LiDAR sensor, you can actually do object avoidance, which includes having multiple cars on the track at the same time. So in a standard event where we're teaching people out of the box, we're going to use this single camera. It's 1 car on the track at a time through a time trial process. The advanced one, I just did a race about 4 weeks ago where they did intro group and then they hit an advanced group. And in the advanced group, we'd put 4 boxes on the track and you would have a time penalty if you hit any of the boxes. And I'll kind of show you how the car learns that here in just a little bit. So let's quickly talk about some key terms in reinforcement learning. And this will make sense to understand how your autonomous driving cars will understand. No, the cars do not talk to each other at all. They use the sensors, right? So the camera is a sensor, and I'll talk about this in a minute. They use the cameras to just see what's around them, and then they make a decision on what to do based off those sensors. So in reinforcement learning, there's multiple terms, and this is how Tesla, Ford, anybody is training their model to automatically drive their vehicles. This is what all of those companies are doing at an introductory level, and then adding additional sensors and moving forward. So like this car here has 1 sensor. Teslas will have anywhere between 16 and I think the latest one has 32 sensors. Depending on the model of the Ford, they'll have between 8 and 14 sensors. I think my wife's Kia has 9 sensors. So there's all different stuff in that. I'll talk a little bit more after a bit about what you can do with this car using ROS as well, and some additional projects. So when we talk about reinforcement learning, the idea is to get the car around the track as fast as you can. If you're doing the advanced, it's without hitting anything. So you think in real life, how do I get an autonomous driving vehicle from point A to point B without hitting anything or hurting any people, right? So the way you would do this is you're going to start with the agent. So in our case, the agent is the DeepRacer car itself. And then you're going to have an environment. And in that environment, you're going to have a goal. And in our case, the goal is, to get from the start to the start line to the finish line, shortest amount of time possible. And then we have what's called the state. And the state is both where the car started from and then where the car went to. So you have an initial state and then you have an ending state. And then you have an action. Okay, there's an action that the car took to get from the first point to the second point. And then you have a reward given every time that action is taken, and an evaluation happens at that ending state to see how well it did. And this will happen over and over and over again. So once this does enough, like for every time it runs, you get a reward that's been issued. Like I said, it'll do it every over and over and over again until it gets to the end of the line or the car crashes. And this is during the training process. So the last concept I want to talk about really quickly is called an episode. And this represents each iteration where the agent goes from the start position to a terminating state. And what will happen is during the training phase, right, where you're training the model, we're going to do a bunch of iterations. It's going to be collected into an episode. Once you have an episode, then you can send that data over to Amazon SageMaker, which will then generate a model based off of that training. It will send it back over to the training environment. And now that training environment will use that model to try to augment the testing phase. This will make a little more sense as we kind of go through a real world example, okay? And some of you have been asking how does the car know about what's around it, other vehicles and stuff like that. So this is what's actually happening inside this car, okay? It's using a 6-layer, multi-layer network architecture. And the input is the neural network, our images captured from the camera. So it's going to go into our first 3 layers. And those first 3 layers are trying to interpret what's in those images. So that image there is an example of what it would see on a track. And so those first 3 layers are trying to pick out, hey, there's a corner coming up. There's the center line and there's the edge, the white lines, edges of the track. So those first 3 layers for every image, it's trying to pick those out. Now this is happening at 15 frames per second on this car. Some people are like, well, that's not very fast. Remember, this just has a small Intel Atom processor. And at 15 frames per second with 2 cameras plus a LiDAR sensor, that's a fair amount of data to process 15 times per second. It then has to then run through the next 2 layers, which are trying to decide the best output. So everything that you see in the middle is actually a part of the reinforcement learning model that gets output during the training process, right? And this is what's running on the car. So the car automatically is making a decision based off what it sees. And then if the last step is it creates an output action. That output action comes out of the inferencing engine, right? And then goes to open source robot OS. That open source robot OS then runs through these cables in the bottom, which tells the servos and the motors which way to steer and how fast to go or to hit the brakes. Does that make sense on what's happening inside the car for a standard car? Yeah, I always forget about the CNN acronym. I can get that back over to you, but it's like canonical network or neuro networks or something like that. I always forget what it is. So many acronyms running in my head here at AWS. So as I mentioned, this is just a computer, and that's the base component that's on here. You can add additional software. There's blog posts all over the internet. Yeah, convolutional neural network. Thanks, John. There's additional software that you can add on to this. For instance, AWS recognition. Does anybody know what AWS recognition can do for you? Identify objects, 100%. So you can upload pictures of your kids in there. And then if you run this recognition agent on here, each image can be sent to recognition. Then you can get a Boolean back or to see if it's one of your kids or not. If it is, you can have a USB relay added to this on any of the ports. You can update the code and have that relay be triggered. That relay could be mounted onto a Nerf gun, and now you can shoot your kids automatically. So there's fun things that people have done with these cars because it is just a computer and it's got multiple open USB ports that you can play around with. So let's step back, and I mentioned, you know, in order for this to work, we've got to give the model, the model's goal is to have the maximum reward possible. And just like with training our kids and our pets, their goal is to get the most treats, right? So how do we do that? So as a participant in this process, you would write a reward function that gives the maximum reward possible for a specific goal that you're trying to do. Now, tracks are different, environments are different, so you've got to try to figure out how to do that. Can anybody tell me what the best direction and speed is to meet the goal of being the fastest car in this scenario that you see on the screen? Yep, straight line. Yep, just go straight and hammer down the gas, right? So if I'm writing a reward function, I would want to give my reward output to be something like this. If the car goes straight in each increment, I'm going to give it a reward of 2. Now, with the black area still being a part of the track, if I do happen to go to that area, I don't want to give it no reward because I'm still on the track. So I'm going to give it a greatly reduced reward, right? And then if I go off the track, I want to give no reward at all. So in the testing environment, when you're training your model, what'll happen is the car will start exploring. It'll do random directions, random speeds. And what it's trying to do is explore the environment and learn what the best direction and path is to go. So it's learning on its own. Yes, this is a simple environment. I could train it to just go straight, but if I had multiple cars on this track, I could run into things. I could put a box in like the 5th spot, and now the fastest isn't going perfectly straight. In this case, though, without boxes, yes, it's going to go there. So as it explores over and over and over again on those what we called iterations, it's going to combine those into an episode, do some training on a model, bring the model back. Once it becomes highly efficient, we say that it's now exploiting the environment because now it knows exactly what to do. Is it totally random? Yes and no, Mark or Jason. I'll tell you it depends. You can actually modify in the training environment, and I'll show you that here in just a few minutes. So out of the box, it's going to do some exploration based off of some directions that you give it, which I'll show you in a minute. So it is random within some guidance that you give it. And the guidance also tells you in the training environment, this is on track, this is off track. So that's why when it goes off track, you see it being reset and it keeps exploring the environment. I liken this to when we all were kids and we were looking for the cookie jar, right? You would start exploring cabinets in the pantry and the kitchen, like all over the place. The first time you find it, you're like, that's awesome. Your parents found out that you now know where it's at, and they move it. Now you start exploring again, and you got to find it again. Well, after you found it a couple times, you start building a pattern of where your parents tend to hide stuff. And now you kind of have more of an exploitation pattern, because I know to go look in these few places. I'm not going to go look in the dishwasher. I'm not going to look in the refrigerator, right? I'm going to go look in these specific cabinets or behind these areas. And now you're doing exploitation. You've got it pretty much down. And that's really what our goal is in training these models. And that's where convergence really happens. And it's where your total reward over your episodes gets so high that your model does a really good job and stays on course and gets around as fast as possible. Good question, Jason. The answer is no, because if I can get back to the center, so Jason's question, if we go off the road, if you go off the center line and get to a point 2, which is still on the road, it's just like, think of it as on the shoulder of a highway, you're going to be better off to get on the road and not stay there. Your goal is to get the total highest reward possible. So back to the question earlier, is it just randomly picking things? The answer is yes, but you get to determine, in this case, what that action space is. And in real life, think back to the stock market or the supply chain stuff, you're gonna pick what the possible actions that the model can test out, you're gonna pick what those are. And in our case, those can be specific steering angle and speed, multitude of those, that you can specify. Now, in this case, that means you could get some really herky-jerky steering when it's trying out and stuff like that, but you can simplify this down. Your other option is what we call a discrete or a continuous action space. And in a continuous action space, you're just going to put the maximum left turn, the maximum right turn, the minimum speed, the maximum speed, and the model or the training system itself will randomly pick those out at first. But as you go through some episodes and it generates an initial machine learning model based off of what it's already learned previously, it will start using that model plus some random action space to get there. I'm going to actually pull this up in the console here in a little bit so you can see this. Yes, you can, Jeff, and I'll show you that in the console. So in the console, you're going to program your own reward function. We've got simplified our console to where you need no development skills at all. You don't need any machine learning skills at all. We've got example reward functions. We've got example parameters that you can use to try to determine where your car is at on the track and what you want it to do. So as you work through your reward function, and I'll kind of show you this is how the reward function was written for that straight line example. These are the parameters that you can bring in the training environment. So every time the car takes an action, I'm going to move forward in this steering degree and this speed. It's going to run through your reward function and it's going to get a reward back. As it goes through all the way around the track, it's going to add all those up. That's the total reward for that iteration. So its goal is to get the maximum total reward for that iteration. So these parameters, like some of them are all the wheels on the track. In our races, only one wheel has to be on the white line. So we're kind of like what we consider a traditional ball sports in the US, where the ball has to go completely outside the white line to be off, or to be considered off the track. Same thing in DeepRacer. We have some of the other example parameters are distance from center, so you can calculate that absolute value. And this is what's being used in the reward function for that center line driving that we were talking about before. So that reward function for this example, what would it look like? So every time the car moves forward, we're going to read an input parameter from the testing environment, which is how wide the track is. And we want to know what is the distance from the center of the track. We're going to split the track into sections. Marker 1 is that orange space. Marker 2 is the black space. And then marker 3, let's say, is the purple space. And then we're going to do a test and see where the car is. If the car is closer to the center, marker 1, below that or within that distance, I'm going to give it a full value of 1. And then it's going to get less out there. If it's completely outside, I'm going to give it a teeny tiny number because it's probably off the track. Question I get all the time is, should I give it a 0? I will tell you, I have seen very weird things when we give a reward of 0 or none. Sometimes it'll definitely air out if you give it a null reward on the return, and the training will stop. So my recommendation is to either give it a very teeny tiny number or give it a negative number, like a negative 0.1. And that does the best on getting it to train. Yep, you're just going to write little functions that it's going to run through. It's kind of a Lambda process in the back end if you've ever done any Lambda development that you can see. So that's what the reward function looks like. So what's happening is I'm going to jump over into a console and kind of show you what this looks like. And I've actually pre-trained a couple models so you can see what happened. So I trained this model yesterday for a couple hours. And what it's doing is, this is the output of the data. So on the left-hand side, I'm trying to get the highest reward I possibly can. And what's happening is there's 2 other things that are running each iteration. So I've got my green line, which is my total reward, and then I've got a blue and a red line, which are talking about, which is going to talk about how much of the track it completed before it went off. Yep, I'm gonna show you kind of what that works out as. So to train your model, this is just like training any other machine learning model. You have to go into an environment, supply it data, train the model. Once the model's trained, you're going to use that model against new data. So what I've done here, and I actually have another one that's actually running right now. Let me refresh this. So this is a model that's currently training right now. So it spins up a AWS RoboMaker environment with the track I selected. There's 64 tracks available. Now you can pick these tracks based off of a simple circle, all the way up to the very long, very curvy Spain F1 course. It is a lot of hairpin turns, arc turns, left turns, right turns. It's kind of a hard one to train on. If you look in the little image down here, you can see this one looks kind of like some kind of a dinosaur. So it's got a big sweeping left turn, pretty good hairpin right turn, and then a couple 90-degree or a little more turns. So this is actually going through the training process. Once the training process is done, I have a model that I can download and I can install, I can push to this car. Once I push the model to this car, I load it in the inferencing engine, and now I can have it auto run. So if you have a Tesla and you get those updates, that is Tesla updating the self-driving model being pushed to your car. They're not training, autonomous driving vehicles are not training while they are out driving. They are inferencing based off of a model that has already been trained. Your system may be collecting data and sending it back to the company to be trained again, right? Because you might be on new environments, new road surfaces, new cones it's never seen before, stuff like that. But your car is not learning while it's there. Jeff, great question. Jeff has a question. Are you training models for a specific track? The answer is yes and no. For a small short event, you're going to want to train for a specific track because you're going to use that model for that one time, maybe a couple times, but it's going to be for that track. We have numerous customers that run leagues all year round for cash prizes of like $10,000 and stuff like that. They will train a model that they can use on a multitude of tracks. So it's more a generalized model that are super good at a lot of different environments. Okay. So again, this is the training environment, and you can watch it train, and I can keep track of my average reward, right, for the training time. How often is it completing a loop around the track, my blue, and then the percentage of completion during a small evaluation. It'll take the model that's being temporarily made for those episodes and being used, and it'll do a test run, and it'll see how far it gets around the track. So your goal during the training process is to have your reward function written in a way that you can get your red up to 100%, and then your reward function could potentially be extremely higher than 100%. Because remember, your reward function is a total reward of every state taken. So the longer the track, the more states that are taken, the more total reward you could potentially have on a full loop. Make sense? No, you cannot simultaneously feed several cars on the same track those data to do that. It's a single car, and then you can continue training over and over again and continue to add to it. So in actuality, this is what I call a clone 2. So I actually started with this base model. And then what I did is I trained it for 2 hours. And so I have initial data, training data. Then I clone that, it brings the initial training data along with it. And then I'm training it further with a different reward function to try to fine tune it and then make it better. So down here in the system, I can go back and look at my reward function. And in this case, what I tried to do was make the car smoother. I know this is kind of hard to see. But what I did here is I added a steering penalty so that if I'm making sharp turns, which slows the car down, I'm going to reduce my reward. So I'm going to multiply my initial given reward by 80%. So if I'm making a hard herky-jerky turn for that step, I'm going to reduce my reward. And that'll teach the car to apex the corners better and be smoother. The reward function is for every state, which means I start at the finish line and I go this direction, this far forward, I have a new state. I run my reward function, I get an output. Okay, I do it again to a new state, I run my reward function, I get a new output, I add it to my first one. And you do that over and over and over and over again until the training period, right? I put a stop condition in of 2 hours until that training time is done. Okay. Got about 10 minutes left, so I'm going to kind of kick through a couple things here. Yep. Iteration for reward recognition. Yep. Once your model has been completed, you can actually do an evaluation. Ran this one a little bit earlier. The video already dropped off. But you can now see your timing, how much time it takes to get around a lap. You can see how often it goes off the track. So this spins up a virtual environment where you can do that. If you watch the video right as it's done, you can see at different points where it actually goes off the track. You can go back and clone your model and adjust your reward function to make it better. Okay? Once you have your model, there's actually community races that are available that you can actually submit models to. I'm going to talk a little bit about this later because this is kind of changing in 2025 on how that goes. So on the community racing tab, there's a monthly community racing that you can submit to, but you can also create your own community races. So if you have friends that want to do this, you can all do it virtually. You don't need a physical car at all. You can create a community race, send a link to them, send a date and time for it to kick off or to be done by. They can submit a model, and then you can see how the cars did and race against each other. There's customers that create both public and private community races that do this all the time. So this is all done within our portal. If you do want to play around with the cars, like most everything else, the cars are all available on Amazon.com. There's components, replacement components. So all the batteries you might need to replace it, test it, everything you'd ever need to set up an environment, it can all be done there. To connect to these, to upload the models, you can either do it by USB key, you can putty into it, or you can web browse to it. So I have this one on my Wi-Fi here at the house. I have a tablet on the Wi-Fi, and I'll just put it on there and control it around the house, chase my dogs a little bit, can do that stuff. We've got all of our input parameters are available on our website with example code on it. So I tell people no experience necessary for this. I actually had a global company out of St. Louis do this, and their HR director of global HR didn't believe us. She got involved. She took 15th out of 330 participants. She's never done any coding or anything like that. She loves it. She's participated in multiple since that initial one. After your model has been trained, you can actually download the logs from this page right here where the training's done. So right there, you can download the logs. You can then import those into SageMaker, and you can actually review the decision it made and kind of try to figure out why it did that. It's pretty cool that you can do that, and you can use this to advance your model even further. On top of that, there's a wonderful video this guy made a few years back. If anybody's into racing and likes the game Trackmania, this guy actually used a DeepRacer process to train a model to try to beat Trackmania, to auto beat him in Trackmania. He's pretty good at it. He actually walks through, and so what you see here is logs from the training process. So green is a high reward, yellow is a middle reward, right? Orange is even lower, and then red is a no or a negative reward. So this is a visual of what it looks like during the training process as a model is being trained. This is a pretty cool video because he talks through the challenges that you have when trying to train a model to do something like this, which goes into, like in your business, the challenges you would have there. I have all these links available for you at the end here, and I can share those out. We've got tons of videos on like how companies use this as a fun, interactive introduction into machine learning. These are physical races that I put on with customers. They go through training, through a workshop, spend time. We bring in a track, the cars, set it all up for them, and then we have a fun talk trash race and do all that stuff with our customers. So there's that. All right, the last thing I want to touch base on, and then I'll get you guys out of here, is what's coming up next. I will actually be at reInvent. I'll post these links here real quick. I will actually be at reInvent this year. If you're going out there, come find me in the Venetian area. I'll be running DeepRacer there. We'll be running Monday through Thursday, Monday through Thursday, come and see me. The DeepRacer services itself is being deprecated at the end of the year. We are moving it to a solution that you can deploy in your own AWS account, and you can run it whenever you want to as a customer. We've open sourced our DeepRacer event management service, which makes them having fun. You can actually see my head there in that picture on the bottom from reInvent last year, but I'll be there again this year. So that's what DeepRacer is. That talks about reinforcement learning, where we use it in businesses, how this is a fun kind of a tech adjacent fun thing to get and play around with it if you're into that type of stuff. So if you have any questions, look me up, hit me up. I'll answer some questions here until it's over, but we'll go from there. Great question, Mark. How much difference is there between a physical race and a simulation? The answer, what's the proverbial IT answer?
It depends, right?
Yeah. So lighting is a huge difference with these cameras. We'll get into places where there's a reflection down low. So think about driving into the sunset and you can't see the lines on the track. And with the camera where it's at, that is our #1 issue all the time, is lighting in the environment. There's different types of tracks too. There's vinyl, there's carpet, there's some harder surface stuff. So we actually have parameters in the training environment that are tailored towards more of a carpeted type surface. So if you have some of the others, I've seen where these cars get up onto 2 wheels almost on a carpeting surface or a vinyl surface with the rubber tires on the rubber. So it does make a difference, and there is some variance. Any other questions? Awesome.
And Eric, if you have any links that you want to share, I'll email them out to everybody that came. If you want to either the presentation or a link to the presentation or whatever, I'll send that out in an email. Just make sure everybody can find the things you talked about.
Sounds good. I'll send you some stuff over.
Okay. Well,
And,
Eric,
thanks for the participation, people. I like it when people, chime in and stuff. I don't like to just present for an hour. So appreciate you all getting involved and chatting in and stuff. So
yeah, well, Eric, thank you so much for coming. This was very, very interesting, and I'm gonna go look up some more stuff after this. And I think everybody benefited from getting an idea of what's out there. So this is very exciting. Thank you so much for taking the time to talk to us today.
no problem. Have a good one, y'all.
See everybody next week.